Good everyone, my name is Graphics. Today we'll be looking at this example on cam. It says to be what? A plate cam to operate on a flat follower, right? So the data given for this cam is 0 degree to 120 degree, is lifting 32 millimeter with what? Uniform velocity. 120 degree to 180 degree, it dwells. 180 degree to 360 degree, it falls with what? 32 millimeter with simple harmonic motion. The cam rotation is what? Anti-clockwise. Nearest approach of the follower to the cam center is what? 32 millimeter. Camshaft diameter is 24 millimeter. Now let's see. When you are ever given a question on cam, the first thing you have to do is for you to draw your table and align all the parameters given. Now this is what I mean here. So this is how you table it. You're going to put them in a tabular form, all the parameters given. Now we're giving our camshaft diameter to be 24 millimeter. We're giving our camshaft meter sheet, which is the closest approach, right? The nearest approach of the follower to the cam. So we'll call it the cam meter sheet, which is what? 32 millimeter. Then the lift, it's lift with what? 32 millimeter. So from 0 degree to 120 degree, it rises, it lifts with what? Uniform velocity. Then from 120 degree to 180 degree, it dwells, that means it rests. Then from 180 to 360, it falls with simple harmonic motion. Then the cam rotation is anti-clockwise. And the type of follower used in this kind of cam is what? The flat follower. There are different type of follower. We have the knife edge, we have the roller follower, we have the flat follower, and so on and so forth. So now we are going to show this in a diagram, represent this in a diagram. So now let's start. The first thing you do is to draw your horizontal axis this way and your vertical axis this way. That's the first thing you do. So we've gotten our center point here, right? Now the next thing you do again is to draw the first thing, which is what? The cam. What is it? You draw the first thing, and that will be what? The camshaft. And the camshaft diameter is what? 24 millimeter. So we'll do that. So if diameter is 24, that means the radius will be what? 12. So I'm going to measure my 12 millimeter radius from 0, and I'll go to this point here. This is 12 here, right? I'll come to this point. This camshaft is very thick, so this is here. I'm going to draw one circle. Right? That's the first thing you do. You draw your circle. Now the next thing you do is to draw the camshaft meter sheet. Now with the camshaft, that is the closest approach to the cam, and that is what? 32 millimeter. So I'll go to 32 millimeter and I'll do that. So I'll measure 32. So now you don't need to take the radius. It's just taking the full measurement of it, which is what? 32. So go there, measure 32. This is 32 from 0 to this point is 32. And I'll come to this center here. I'm going to draw this guy, and that will be faint line. Right? Now the next thing we'll draw is the lift. Now the lift is what? The lift is giving us also 32 millimeter here, right? You can see that. So it is not a diameter, it is just a value. So I'll measure 32, and 32 I'll measure will be from the top of this guy here. Are we good? So from the top of that guy there, I'm going to measure 32 from here. So this is my 32 here. So the lift, you don't have to divide, it doesn't start from the center, it starts from on top of the meter sheet, right? So that's 32. So I'll now place at the center here and take it to this point. Can you see that? Then I'll draw my circle to this point and I'll draw. So in drawing, I'll have something like this. Faint line too. As you can see, are we good? So in doing that, the next thing we'll do is to divide this circle into 12 if you want to, or into 24, but I will divide it into 12. So dividing into 12, with the way I used to draw the circle here, I will divide it this way. So I'll place my compass here, I'll mark up, right? I'll come to this point too, and place my compass here, I'll mark here. I'll come to this point too, place my compass here, and I'll mark left and what? And right. So in doing that, I'll take my ruler and I'm going to draw another point passing through the center. From this point to this point here, I'll draw, touch here, faint line from this point to this point here too. I'll also draw from this point to this point here too. I'll also draw from here also to the center point too. I'll also draw. So in doing that, I successfully drawn my divided into 12 equal parts. Now it's telling me something that what it is moving, the cam rotating in what, in an anti-clockwise manner. If you can see, says the cam rotation is what, anti-clockwise. If the cam rotation is anti-clockwise, then the roller rotation will be what, clockwise. So this is what they meant here. So if my cam rotation is anti-clockwise, this is the cam here, this guy inside the cam, so it's going what, anti-clockwise, so it's going backward this way. So then the follower rotation will be what? Will be clockwise. So at this point here, they are taken. Now we'll divide into 12, so we'll start moving from 0 to what? 360. So this point here will be, this point here will be 0 degree, move in this direction. Here will be 30 degree, here will be 60 degree, here will be 90 degree, here will be 120 degree, 150 degree, 180 degree, 210 degree, 240 degree, 270 degree, 300 degree, 330 degree, then 360, right? So that's the next step you do. So the other thing you do is this: you're going to draw your cam profile diagram. You see, from here to here is what, 32, right? So you're going to project that point. You project the point. Look at what I want to do now. From this point to this point here, I'm going to project it outward. My faint line. So I'll project it from here. I'm having this, right? You can draw it anywhere. So I can come here and draw my cam profile diagram anywhere I want to. So what I need is, I need 32 here. So let me do it below, right? So you can draw my cam profile diagram up here at this point. So let me draw it here, right? So let's do that and see. So what I will do is this: I am going to draw the vertical line this way, the horizontal line this way, right? It can be anywhere, and I'm going to place a perpendicular line like this. So let me do it this way from this point. So this is my perpendicular line, right? So this line here, I'll divide it into 12. So with the help of my rule, I'll take my ruler and I'm going to start. This is 0. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means this is 0 degree, this is 30 degree, this is 60 degree, 90 degree, 120 degree, 150 degree, 180 degree, 210 degree, 240, 270, 300, 330, and 360. Is that okay? Now what I'll do is the lift here is what, 32. So half of it is what, 16. So I'm going to measure the 16 from here. So this point here is 16. This 16. So I'll place it here. I'm going to mark up here, and I'll come here. Since I say it is what, uniform velocity, so draw my line like this, front line, right? And I'm going to divide it into, it depends how I'll divide it. If you look at this very well, it's telling us that what it is what, it's lift with what, 0 to what, 120, right? So how will we know 0 to 120? Let's start from here. 0 to 120. Let's see, this is 0, this is 1, 2, 3, 4. So 0, 1, 2, 3, 4. So I'm going to divide this circle into 4 equal parts. Now this is what I mean here. Before that, let's close it up first. So closing it up is, I'll come here, I'll draw my guide this way, right? And I'm going to project all my points upwards. So the 30 degree will go up, 60 is going up, 90 is going up, 120 is going up. So this is what we have. Right? So in doing that, I'm going to divide this into 4 because I'm moving from 0 to 120. And 0 to 120 is what? This is 0, 1, 2, 3, 4 is 4. So if I divide this into 4, this is 1, and this is another one. Then the center, right? So let's see how it goes. So I'm moving to what, 120. So I project on my line from here to stop at 120. This one too, this is 120 here. This one is coming to stop at what, 120. Come stop at what, 120. So let's see. This is 0, is lifting, to this point here, right? So I'm going to join it together. Now the next thing is, it says from 120 to 240, from 120 to 180 it dwells. Look at what they wrote it here. It says from 120 to 180 it dwells, it's at rest. So I'll come here, 120 to it dwells, right? So if you look at it very well, it dwells. So this is 120 to what? 180. So it's at rest from this point to this point, right? It dwells. So let me do that. From here to here, it dwells. Now good. Now the next one is, it falls now with what? It falls with simple harmonic motion. Now how will you know how to divide that particular guy there? This is what you do here. It's falling in simple harmonic motion. Now I will repeat the same feat I did here. I know that from this point here is 32. So I'll come to this point too. I'm going to mark and draw my semicircle. And I'm going to divide it into 6, because from here what's remaining? This is 0, 1, 2, 3, 4, 5, 6, right? So I'll divide my circle into 6. So if I place it here, I'll cut up, I'll cut down, I'll place it here, I'll cut here, and I'll place it here, and I'll also cut here. So I'll move them to the center. So moving it to the center, this point to this point, from this point to this point, from here to here to, from here to here too, right? So I'll project all those lines. From this point I'll project it to stop here. From this point project it to stop here. From here to come stop here. This point to come stop here, and this to this point. So let's see, it's falling. So from 180 it starts falling down. From 180 it starts falling down until it gets here, right? So with the help of the French curve, you're going to join all these points together, and let's do that and see. So by joining it to a French curve, you're going to have an arc like this. Is that taken? So now let's apply this to our circle. So this is what we call the cam profile diagram, joining those points together. Now what we'll do here is this. Now we're going to transfer this point to this point here, to the circle. Let me reduce it a little bit. Look at what I'm explaining now. From 0, starting from this point here, 0 degree, that is point 1. Then the next one is what? 30. You know what I mean? You take it to 30, take your compass, you place it here, and you're going to move it to this point here. Can you see? That's the thickness. And you come to the next guy, which is 30, and you place it on the diameter sheet and you mark. That's another point there, right? You go to the next one again, which is 60, and you're going to place it here from 60 up to what? This point here. Can you see that? And you go to the angle of 60, which is this. This is this, right? And you place it on this point on the diameter sheet. We are going to mark 60. You do the same thing. You go to 90. You go to 90. You move it to that point too, where they meet. Can you see? This is 90. And I'll come to where 90 is. And I'll place it on the point here and I'll mark. Right? So that is 90. You go to 120. This is 120. You come to where 120 is and you mark. It's touching the circumference, right? So 120 here, 150 here, 180 here. Why? Because of what? They are all at the same point. They are resting. So from 120 to 180 is touching the circumference of the circle. Is that taken? So it's touching where? The circumference of the circle. Look at it here. So from 120 to 150, touching the circumference of the circle. That I'm having 120, 150, 180. They are all on the same point, right? So I'm going forward now. So 120, 150, 180, they are resting, they are dwelling. So they're on circumference. That's why you see all of them will fall on the same points here. Can you see? Now the next one is what? 210. I'll go to where 210 is. I'll place it the same way. And I'll come here. So in doing that, I'll go to 210, place it on the line of 210. So this is the point of 210 here. I'm going to mark it there. And I'll go to 240. I'll mark 240. Take the point of 240 here. And I'll go and do the same thing here on 240. Place it on the circumference here on the meta sheet. And I'm going to mark. Then the next one again is 270. I'll do the same on 270. 270, place it here, right? Take the circumference to the point of 270, place on this meta sheet, and I'll mark. Then I'll go on 300 also. This 300 here, right? I'm going to mark also on the line of 300, right? Then the last one is what? 330. I'll mark. Is 330 here, then back to 0. So now I will now use my French curve. My French curve. I'll now join all those points together. So use your French curve and join all those points together. So this is what you are going to be having. So this is the movement of what? Of the follower. Since it's a plate cam, at every instant, at the first point here, you'll be drawing a line tangential to that point. At every point, you draw a line tangential to it. At every point, you draw a line tangential to it. Just like that. Tangential to it. To show that it is what? The plate follower for every instance. Right? So come here too. And where you see it is what? The plate follower. So this is our plate. Just draw the symbol here to show that it is a knife edge follower, and a plate cam follower. So just taking it, come here, so you're taking it and put it up, right, and you come here too, close it up, put it up, and there goes up, and you close it up, and you have this. To show that what it is a knife edge follower. I mean, it is a plate cam, a plate follower. So this is what we are having, right? This is what we are having. So thank you very much.